Okay, so in this video, we're going to start learning how to put math. Okay, we're also going to learn how to do a new page. So I'm going to do new page, and I'm going to start typing stuff. So if you just write new page and don't type anything, it doesn't do anything. Okay, so now I'm going to write a line. Okay, I'm not going to keep that, but I just want to show you what's going to happen. Okay, new page. Okay, so now let's do math. Okay, so there are basically two ways that I think about doing math. You can either have like math written like in line, like in a sentence, or you can kind of have an equation like set off. So let's do two of these. Let's show you the first method first. So the Pythagorean theorem, and now I just realized I don't know how to spell Pythagorean theorem. So hold on, let me see over here. I have it pulled up over here. Pytha. The Pythagorean theorem says that, okay, and so now I'm going to write a squared plus b squared is equal to c squared. If you want to have math like in a paragraph, like not offset by itself, but like in a sentence, you do the dollar sign. So I just typed in $1 and it automatically put the other dollar sign. So it's going to be x squared, which is x caret 2, plus y squared, sorry, I want to do a squared plus b squared is equal to c squared. So a squared plus b squared is equal to c squared. Okay, now if we read this, like if we read this just in a text file, like if you were, for whatever reason, texting math to your friends, and they said, what's the Pythagorean theorem? You would text something like this, and everybody would just read it as a squared plus b squared is equal to c squared. But look at how LaTeX handles it. Okay, and look, it makes it into sort of the mathy thing that we have here. A squared plus b squared is equal to c squared. We could sort of go on. Let me show you some other examples. If the equation of a circle is, okay, x squared plus y squared is equal to 9, then, okay, let's solve this for y in terms of x. Then y, so what is y going to be? Y is going to be plus or minus 9, plus or minus the square root of 9 minus x squared. So this is going to be very simple. So the square root part, I'll do that first and then do the plus or minus. So it's just going to be backslash square root, and then we're going to put the curly brackets, and everything under the square root goes in the curly brackets. So this will be 9 minus x squared. Now for plus minus, there's another command, backslash pm, and we're going to recompile. And this is what we get, except I put a 6 instead of a 9. So LaTeX will not tell you if you made a mathematical error. Okay, so let's do something with another symbol. Well, let's do something with an integral symbol. Let's say you don't remember what the command is, or you don't know what the command is for the integral symbol. Well, there's this website called Detectify. So I just Googled Detectify. I have this. It comes up with this, and you actually draw the symbol that you want, and it'll basically do a pretty good job of telling you what the code is over here. So let's say we want to do an integral of some function. We have something like that. Okay, backslash int. Okay, great. That's what it is. So I'm going to come over here and say we can use the fundamental theorem of calculus to compute. Okay, so we want the integral. Let's say we're going to go from 0, so underscore 0 to, let's say, pi, caret pi. So if I just run this code, it's going to be the integral. It's just going to be the integral sign from 0 to pi. So we have that right there. And let's say we want to do cosine x. So backslash cosine x dx. And then this is going to be equal to sine of pi minus sine of 0, which is equal to 0. Okay. And this is what we get here. Okay, so many of the math commands that you want to do, they're going to be fairly intuitive. Okay, backslash square root makes sense. Backslash sine makes sense. Backslash cos makes sense. Backslash tangent is tangent, and all of that stuff. Let's say you want to do a derivative. So we can say the derivative is, okay, frac gives us a fraction. Okay, it's going to be a fraction followed by two arguments. the first argument is the numerator, the second argument is the denominator, so I'm going to put df dx is equal to, and I'm just going to write the limit definition of the derivative. Well, the command for limit is, again, this is all very intuitive. It's \lim, and then I want the limit as h goes to 0, so I'm going to do underscore and h to, h \2 0. Okay, I'm going to do a fraction because this is going to be the difference quotient, f of x plus h minus f of x over h. And if I run this, we get this. Let's say you don't want to use h. Let's say you want to use delta x. For that, we could do delta x here, delta x here, and delta x here. And so I'm going to run it. And again, we have delta x instead of h. Okay. So that is it. That's going to be our first video on math mode. In the second video, I'm going to show you how we can do equations that are kind of set off in the middle of the page, like a, it's not in line. It's a separate equation, like its own paragraph. If you don't understand what I mean now, you'll see it in the next video.